Hey everybody, today's Wednesday, September 2nd. So we are going to look at some applications of the theorems that we just talked about the last 2 days. So if things are still not making sense, please come to me, let me know. Remember that Group B is going to take the quiz tomorrow, Thursday. We're going to review a little bit in class to begin class, but then you will take the quiz tomorrow. So again, Group B is taking it Thursday. Okay, and Group A is going to take it Friday. Okay, now Group A, again, we might have a little bit of time to review at the beginning, I would assume, since we're doing the same with Group B, but just be aware and be prepared. Okay, so let's get started, shall we? Applications of Pythagorean theorem and triangle inequality theorem. So example 1 says that we have a perimeter of a square that is 64 inches. What is the length of its diagonal? Okay, so key points here. First of all, perimeter. Remember that perimeter is the outside of a shape. Okay, so it's everything around the outside, right? And then a square tells us that all the sides are the same, right? And then what is the length of its diagonal? Okay, so since we have a square, let's go ahead and draw it. Okay, and again, all these lengths are the same size. So since it's a square and we know that the perimeter is the distance around the outside, then we know this entire distance around the outside is 64 inches, right? So that's the perimeter. Well, if we know it's a square, then we can divide this up evenly among the 4 sides because all 4 have to be equal, which in this case would be 16. So 16, 16, 16, 16. Okay? All right, so then it says, what's the length of its diagonal? All right, so here's where it comes into play. We are going to use Pythagorean theorem to solve for the hypotenuse, right, for the diagonal, because we know that a square has 4 90-degree angles. So we know that this is the hypotenuse. Okay, so let's go ahead and set it up. We have 16 squared plus 16 squared equals our hypotenuse squared. Okay, 16 squared is 256. 256. Okay, which is what? Here, we're going to move this up to the side, actually. I think that's what we'll do. There we go. So 256 plus 256. By the way, if you don't have Desmos on your iPad, you should download that. We're going to use it a bunch. So c squared, so take the square root. Take the square root. Well, 512, as we just did, breaks down into 256 times 2. And we know that 256 is 16 squared. So this is 16 radical 2, right? Okay, so that is our C. So our diagonal C is 16 radical 2, which if we put that in our calculator, 16 and then radical 2 is about 22.63 so inches, which makes sense because your hypotenuse should be a little bit bigger than everything else. Okay, so there's your answer. Let's move on to number 2. Number 2 says the 2 shorter legs of a triangle are 9 and 12. What length must the third leg be for it to be an obtuse triangle? Okay, so here's the other theorem, right? How do we know that something is an obtuse triangle? Well, we know when the hypotenuse is bigger, the hypotenuse squared is bigger than the side squared. So if the question is saying how long must it be, then this must be a true statement, right? So let's go ahead and plug this in for our legs. I'm going to keep this as c squared. Okay, and this is 81, this is 144, c squared, 225, c squared, take the square root. Okay, and you get 15, right? So 225, if you're not sure, hopefully at this point you know it, but take the square root of 225, 15 is less than c. Okay, so what does that mean? That means that your hypotenuse, or the third leg, c, has to be greater than 15. Okay? All right, there's that. Last question here before I let you get started on the practice for today. Mr. Middleton is running at a park with a rectangular path. Notice, by the way, I'm trying to really look at the directions and figure out what I'm using, okay? So Mr. Middleton is running on a rectangular path. He jogged 2 miles at its length, 1.5 miles along its width. He took the diagonal path back to his starting spot. So the question is, how much shorter is the distance along the diagonal path than what he already ran? So we're talking here like we need to find the diagonal path. So we have a rectangle. Let's say Mr. Middleton, the assistant principal, started here. He ran 2 miles. Okay, then he went another 1.5 miles. Okay, and then he went from this point all the way back. So we need to find, if this is a 90-degree angle, what is our diagonal. Again, let's set it up. 1.5 squared plus 2 squared. Okay, 2 squared is 4. 1.5 squared is 2.25. So that is 6.25. Okay, so let's take the square root of that. Square root of 6.25 is 2.5. Okay, so x is 2.5. So the question is not what is the diagonal, it is part of it, but it says how much shorter is the distance along the diagonal than what he already ran. So he already ran 2 plus 1.5 miles, which is 3.5 miles, and then the hypotenuse was 2.5 miles, so it was 1 mile shorter. And there's your answer. Okay, so today in class we're going to work through a couple of these examples, do this practice for homework. Once you finish, the review is also posted in Canvas, so you can take a look at that to help prepare for the quiz for tomorrow if you're Group B or Friday if you're Group A. Good luck. I'll see you guys in class.